Okay, we are on lesson 2, but before I get into lesson 2, I just want to show you where I'm posting the homework answer key because I want you to be able to check that. It's right here in the announcements. It's like the last thing I did, but you can also get it in classwork. So if you hit classwork in Google Classroom, and if you scroll down, there's going to be a module that's Unit 1 answer keys. If you click that, there's the notes answer key, and then this is what I want you to take a look at. It's the homework answer key. I'd like you to pause the video and check your homework. Make sure that you got what I got. For question 2, I put it in both point slope and slope intercept form. But for question 3, I put it in point slope form because it's just way easier. So again, make sure you pause the video, check your homework, and then you can unpause it and get into the second lesson. Yesterday, we looked at equations of lines and we looked at slope intercept form. So that's y equals mx plus b. And then we looked at point slope form, which was that new form, y minus y1 equals mx minus x1. We're going to continue with equations of lines, but we are going to specifically look at two lines that are perpendicular to each other and how we know if they're perpendicular. So in this first example, it's asking us to determine the slope of both line segments in the graph. So in this first one, we want to find the slope of AB. And we also want to find the slope of CD. So AB. I could use the slope formula, which yesterday we talked about was y2 minus y1 over x2 minus x1, or we can just count. I'm going to go ahead and count, go from A to B. So up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 10/15. And I'm going to simplify that to 2/3. Okay, let's take a look at CD. I'll do the same thing. I'll go count. So I'll count from C to D. Down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Down 12, right 1, 2, 3, 4, 5, 6, 7, 8. Down 12, right 8. Since we're going down, it's going to be a negative. Our slope is going down. The line is going down. That's a negative slope. Okay, so negative 12/8. And that's going to simplify to negative 3/2. If we went ahead and divided by 4, 12 divided by 4 is 3, 8 divided by 4 is 2. Okay. They told us right off the bat that these lines were perpendicular. So I don't think I mentioned that, but it did say we had two perpendicular lines. AB and CD are perpendicular. And here's the symbol for perpendicular. It's like this little box right here. Okay. They told us that the lines were perpendicular. And when we found the slope of AB and the slope of CD, we got 2/3 and negative 3/2. So you might notice something about those two slopes. Let's do it again for two different, completely different perpendicular lines. So in this case, GH is perpendicular to EF. That's our symbol for it. Symbolically, this means perpendicular. Okay. So they tell us off the bat, GH and EF are perpendicular. Let me go ahead and find the slope of GH, and then I'll find EF afterwards. So GH, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right 1, 2, 3, 4, 5. Down 10, right 5. So that is a slope of negative 2. And now let me find the slope of EF. Okay, slope of EF, that's going to be up 1, 2, 3, 4, 5, 6, 7, 8. And right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Up 8, right 16 for a slope of 1/2. Okay, let's take a look at these perpendicular lines and their slopes. So these two lines are perpendicular, and we'll take a look at their slopes. These two lines are perpendicular, and we'll take a look at their slopes. So I guess the question is, what do you notice about their slopes? Hopefully you realize that they're kind of the flip of one another. 2/3, 3/2, they're flipped. 2/1, 1/2, they're flipped. And they're also negatives of one another. They're negations of one another. We call that negative reciprocals. So I'm going to say the slopes of, I'm going to use the symbol here, perpendicular lines are negative reciprocals. That's going to be a phrase that you want to be comfortable with. Negative reciprocals, that occurs when you have perpendicular lines. Okay. Next part says, write the equation for AB. I'm going to write it in slope-intercept form. It looks like the intercept here is -1, and we have the slope already. So I'm going to say for AB, it's y equals 2/3 x minus 1. The equation for CD, it looks like the y-intercept is at 3. So -3/2 plus 3. 3/2 x plus 3. Let's go ahead and look at EF. EF has a y-intercept of 3 as well, but a slope of 1/2, so 1/2 x plus 3. And GH has a y-intercept of, looks to be +2. So y equals -2x plus 2. All right, it was just easier to write it into slope-intercept form because we had the slopes already and we could just look at the intercepts on our graphs. All right, so here's our definition again. Two perpendicular lines that are neither vertical nor horizontal have slopes whose values are negative reciprocals of one another. Okay. Line segment AB has endpoints -3, 7 and B 3, 15, which of the following would be the slope of a line perpendicular to AB? Okay, well, let's find the slope of AB first. AB is y2 minus y1 divided by x2 minus x1. Okay, I have 15 minus 7 over 3 minus a -3. Okay, so that's going to be 8, and 3 minus a -3, that's really 3 plus 3, so that's 6. Let's simplify that to be 4/3. The slope of AB is 4/3. So perpendicular to AB would have to be the negative reciprocal. The negative reciprocal of 4/3, let's flip it and negate it. That's going to be -3/4. So choice 2. Okay, exercise 3. What is the equation of the line that passes through point C and is perpendicular to AB? So equation of a line. Anytime I see equation of a line, I think two things I need. I need a point and I need a slope. Okay, those are the two things we need anytime we write an equation of a line. It's asking us for an equation of a line that passes through point C. So we have a point. It has to go through C. So let's figure out what point C is. C is 1, -3. So 1, -3. So I have my point. Now I have to find the slope. They're telling us the slope of the line has to be perpendicular to AB. So let's find the slope of AB. So I'm looking at this. It looks like it's up 2 over 3, up 2 over 3, up 2 over 3. Okay, so it looks like the slope is 2/3. If you were unsure of that, you can do the slope formula, or you can count from A to B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So up 10 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. which reduces to 2/3. So the slope is 2/3. We want to write an equation that's perpendicular to AB. So a slope perpendicular to AB would have to be the negative reciprocal of 2/3, which is -3/2. So my slope is going to be -3/2. Now that we have a point, we have a slope, we're going to go ahead and write an equation. Let's write the equation in point slope form. You really should get comfortable with that. It's just the easier way to do it. Y minus y1 equals mx minus x1. And let's make the substitutions. So y minus a -3, that's going to be y plus 3, equals -3/2 x minus 1. So I substituted in 1 in for x1, -3 in for y1, and -3/2 in for m. So that's where we got this from. And that's your answer. Again, don't do anything with it. Leave it as is. Okay, given the points A, B, C, and D, is AB perpendicular to CD? The only way they're going to be perpendicular is if they have negative reciprocal slopes. Let's go ahead and find the slope of AB. Let's find the slope of CD. And let's see if they are negative reciprocals. So AB, I'm going to count it up 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2, 3. So AB up 9 over 3. In simplest form, that reduces to 3. Slope of CD, down 1, 2 over 1, 2, 3, 4, 5, 6, 7, 8. Down 2 over 8. That simplifies to -1/4. So I'm looking at this. 3 and -1/4 are not negative reciprocals. So I'm going to say no, AB is not perpendicular to CD because their slopes are not negative reciprocals. Okay. Notice how I'm using that phrase, negative reciprocals, in an explanation. Okay. All right. Question 5. Which equation represents a line that is perpendicular to the line represented by 2x minus y equals 7? Well, let's figure out what the slope of this line is. So we're going to do a little bit of manipulation here. I'll subtract 2x. So don't forget we still have that negative there. And then to change the negative here to positive, I could divide by -1 or multiply by -1, either or. So we have y equals positive 2x minus 7. So if we want to find a line perpendicular to this line, we have to look at the slope. Here the slope is 2. So a line that's perpendicular to that, would need to have a slope of -1/2. So we have to try to find a linear equation here that has a slope of -1/2. So the slopes, we know where they are. They're in this spot here. So looking at these 4 equations, the one that has the slope of -1/2 is choice 1. Okay, an equation of a line perpendicular to the line represented by that equation and passes through the point 6, -4 is what? All right, we want it to be perpendicular to this line right here. So if it has to be perpendicular, it needs perpendicular slope would need to be a slope of 2. So we could eliminate 2 choices right off the bat. We need a slope of 2. That's the only way it's going to be perpendicular. So not choice 1, not choice 2. So we're down to either 3 or 4. They're telling us that it has to pass through the point 6, -4. So if we wanted to, I'm looking at these. These are both in y equals mx plus b. So I could use y equals mx plus b, substitute 6 in for x, negative 4 in for y, 2 in for m, and that's how we could solve for b. I'm going to go ahead and do that. Negative 4 equals 2 times 6 plus b. Negative 4 equals 12 plus b. Subtract 12, and the y-intercept needs to be negative 16. So it has to have a slope of 2, a y-intercept of negative 16. Choice 4 seems to be the right answer. All right, 2 more. Okay. This was a 2-point Regents question. It's a tricky one. They give us part of point A. They tell us what the y value is, but they don't give us the x value. They give us point B and point C. Determine and state a value of x that would make ABC a right triangle. A right triangle has to have a right angle, and a right angle is created by perpendicular lines. Perpendicular lines form right angles, so that's what we're looking for. We're looking to try to create a perpendicular line. Let me graph the points that they give us. They tell us B is negative 3, negative 1. And C is negative 1, negative 4. And they tell us that A is x comma 3. The only thing they tell us is that the y value is 3. So what I'm going to do with that is I'm going to do this dashed line at 3. 1, 2, 3. And basically, point A has to be somewhere on this line. Now, I don't know where. Point A, whoops, I don't want to do all that. Sorry. Let's do that line again. Okay. So point A has to be somewhere on this line. I don't know where yet, but the y value is 3, so it's got to lie somewhere here. We have to figure out where it needs to be such that it creates a right triangle. And a right triangle is created by perpendicular lines. So why don't we find the slope of BC? The slope of BC, that should be easy. We can just count 1, 2, 3, down 3 over 2. Down 3 over 2. Now, to create a right angle, so to create a right angle, we need perpendicular lines. And we just learned this whole lesson was perpendicular lines. The way that we know that we have perpendicular lines is by negative reciprocal slopes. So we need a slope. We need a slope of 2/3, right? Because that's going to be the negative reciprocal of BC. So we need to get a slope of 2/3. So what I'm going to do is I'm going to start at point B and do a slope of 2/3 until hopefully I reach the red line. So let's see, up 2 over 1, 2, 3. I can't put A there because that doesn't have a y value of 3. Let me do again. Up 2 over 1, 2, 3. That's perfect. That's where A has to be. That's going to give the slope. That's going to make the slope from A to B be 2/3. That ensures that the y value is at 3. So we're all good there. That creates a right triangle. There's another answer you could have had. You could have tried to create the slope of 2/3 from C to A. So if I went up 2 over 1, 2, 3, that doesn't work. Up 2 over 1, 2, 3, that doesn't work. Up 2 over 1, 2, 3, that doesn't work. Up 2 over 1, 2, 3. It goes past the red line. You could make it work instead of going up 2 over 3. You can go up 1 over 1.5 and put it right here, but it's going to be a little bit messy. The best thing was going from B to A up to 1, 2, 3, up to over 1, 2, 3, and putting it right here. It lands nicely on the y value of 3. So let's just figure out what that would be. X would have to equal 2. So this is the point 2, 3. Justify why triangle ABC is a right triangle. I'm just going to say triangle ABC is a right triangle because AB and BC have negative reciprocal slopes and are perpendicular. Okay. Last question here. So right triangle RST has the coordinates 1, 7, 3, 1, and 9, 3. It's asking us to prove that RST is a right triangle. So again, we have to figure out where the right angle is. So looking at the triangle, you could probably see where the 90 degree is. Looks to be right here. So we want to prove RST is a right triangle. And to prove that it's a right triangle, we have to show that two lines are perpendicular. So our goal is to show RS is perpendicular to TS. And the way to show that is by basically calculating their slopes and showing that they're negative reciprocals. That's what we're hoping they're going to be. So let's find the slope of RS. Let's find the slope of TS. Let's hope they're negative reciprocals, and then we'll write a little conclusion if they are. Okay, RS. Down 1, 2, 3, 4, 5, 6, right 2. Down 6, right 2. That's going to reduce to negative 3. S to T, up 1, 2, right 1, 2, 3, 4, 5, 6. Up 2, right 6 for 1/3. Okay, we showed that 1/3, negative 3, we figured out their slopes, and we could see that they're negative reciprocals. So I'm going to say RS is perpendicular to TS because the slopes of RS and TS are negative reciprocals. This means RS is perpendicular to TS and forms a right angle. Triangle RTS is a right triangle. So, I mean, it's unfortunate that I'm not there to kind of stress some of this, but in geometry, it is important to write a conclusion explaining what you found and what it means. So what did we find? We found that slopes were negative reciprocals. What does it mean? It means the lines are perpendicular, they form a right angle, which means we have a right triangle. We have to prove RST is a right triangle, so at the end, we better be saying that it's a right triangle. And everything before that kind of justifies it. All right. So your homework tonight is just kind of the next one down, homework number 2, 1-2. Again, you'll do that and then make sure you submit it on Google Classroom. If you have any issues, again, please email me. All right. Have a good rest of your day. Bye.